Hi, welcome to another lesson on organic chemistry. Today what we're going to do is we're going to look at the alkanes. A brief introduction to the alkanes. So this is our first lesson on alkanes, and in this lesson we're going to look at the structure of the different alkanes, and we'll worry about naming them in another lesson. So alkanes are what we call in organic chemistry a homologous series. And that means that as they increase in carbon number, they increase in a very predictable way. And that because of their structure being pretty much the same all the way along, they have somewhat similar chemical properties, certainly in terms of their reactions. They tend to be quite similar. The thing that changes, of course, is the length of the molecule. As we add more carbons, the molecule becomes longer and longer and longer, and that has some effects on boiling point and melting point, and we'll see that in later lessons as well. So let's go to the desk here and have a look at some of the features of alkanes. So alkanes are a homologous series. Homologous series is a series of related compounds. They are hydrocarbons. Now, hydrocarbons is a term that you must remember, so I'll underline that one in yellow. Hydrocarbons are molecules that contain only carbon and hydrogen. So you don't have any other kinds of atoms in them. They have carbon or hydrogen. So essentially they're kind of a pure organic molecule with nothing else but carbon and hydrogen. They are saturated. They only have single bonds in their structures, and they have a general formula that is CnH2n plus 2. Now I'm going to explain that. So let's look at the simplest alkane. The simplest alkane is C, 1 carbon with 4 bonds, and those 4 bonds are attached to hydrogens. Couldn't be simpler. Okay, so let's have a look at our second hydrocarbon. So, our second alkane. And this one has 2 C's, and they're joined by a single bond, and they have single bonds all around them that are attached to hydrogen atoms. Okay, we'll worry about the names of these things in another lesson. I'm going to do the third one, which, as you can probably imagine, is just 3 C's with hydrogen atoms attached to all the single bonds. And this is our alkane with 3 carbons in it. All right. Now each of these molecules has a different name, and the naming is systematic. Our homologous series have systematic names, but we're going to talk about that in our next lesson. And we can keep going all the way up to as many carbons as you like. So for example, I could do 1, 2, 3, 4, 5, 6 carbons. I put a single bond between every carbon, remember, saturated, only single bonds. And then I have my single bonds coming out of every carbon. There's a spare bond at the end, remember, because there's no carbon there. Oh, hang on, that shouldn't go there. That one goes there. That one goes there. I'm going to have to get some white out or something, because scoring that out is not going to look very good either. But we'll put in our hydrogens. They go at the end of all of these single bonds. Let's try not to put one on that mistake bond. Okay, and if you had a very long piece of paper and a lot of patience, you could draw out an alkane that had 300 carbons now. I've shown you how to draw an alkane. All you do is keep adding carbons and then add hydrogens to all the spare bonds. Remember, at the end, you have 2 extra hydrogens. 1 at each end, because the end carbons aren't joined to another carbon, so they get a spare bond for an extra hydrogen. So at the end we have CH3, CH3, and in between it's all CH2s. So where does this general formula come from? Well, let's write down the molecular formula for these. So this one is C, we've got 1 C and 4 hydrogen, so CH4. Okay, so let's look at this one. We have 2 C, so C2, and 1, 2, 3, 4, 5, 6 hydrogen, H6. Okay, and here we have 3 carbon. 1, 2, 3. So C3. How many hydrogen do we have? 1, 2, 3, 4, 5, 6, 7, 8. C3H8. And up here, this is our 1, 2, 3, 4, 5, 6. This one is C6. And how many hydrogen do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So H14. Now, you can see how the general formula works. If I make the number of carbons equal to N, then the number of hydrogens is equal to 2N plus 2. So let's take a carbon with, if I make C8, okay, how many hydrogens do I have? Well, it's going to be 2N plus 2. So remember, we're going to multiply this together first and then add the 2. So it's going to be 2 times 8 is 16 plus 2, which equals 18. So the answer is C8H18. Okay, and you can see how that works actually, because when we look at the structure, I know I've made a mistake here, but every carbon has 2 hydrogen and then there are 2 extras. So that's the 2N, so 2 for every carbon plus the 2 on the ends, the 2 hydrogens on the ends. So that's how the general formula works. We'll look at general formulae in every other homologous series that we look at, and you'll be able to pick it up pretty quickly. It's a relatively simple thing. So I'm going to leave it there. That's an introduction to the hydrocarbons. The alkanes. First introduction, and we'll look at how we name these things in our next lesson. And hopefully that's all been done in less than 8 minutes.